In organic chemistry, a functional group is like a family name that tells you about a group of related individuals. Just like how members of a family share a surname and some common traits, members of a functional group, family, have a set of similar atoms that actually determine how they behave chemically. Think of it as meeting the hydroxyl family or the carboxyl family, each with its own unique style and behavior. These groups give organic compounds their personalities and dictate how they react in different situations. So now let's talk about some common functional groups. First up, we have the hydroxyl family, and their bonding nature is an OH group attached to a carbon atom. This family's surname is OL, so when you see an OL at the end of a compound's name, you know it's a member of the hydroxyl family. Examples, you have ethanol, propanol, and butanol. Every molecule in the hydroxyl family likes to bond with water due to its polar nature. A famous member in this hydroxyl family is ethanol, which you might recognize as the active ingredient in alcoholic beverages. Next up, we have the carbonyl family, which is carbon double bonded to oxygen. This carbonyl family has two subfamilies, aldehydes and ketones. In aldehydes, the carbonyl group, which is carbon double bonded to oxygen, is bonded to at least one hydrogen atom. This subfamily is always found at the end of a molecule, just like a family member who prefers staying at the edge of a dance floor. Aldehyde subfamilies are known for their al endings, like ethanol. So all aldehydes end with al. For ketones, the carbonyl group, which is carbon double bonded to oxygen, is bonded to two other carbon-containing groups, which we refer to as the alkyl or the aryl groups. Meaning the carbonyl groups actually are found in the middle, surrounded by two other groups. Compounds that belong to the ketone subfamily end with -one, as seen in propanone, which is also called acetone. Our next family is the carboxyl family, aka the carboxylic acids. In carboxylic acids, the carbon atom is double bonded to an oxygen and then single bonded to an OH group. This structure makes the carboxyl group acidic, giving carboxylic acids their sour and reactive nature. Their signature ending is oic acid, like in ethanoic acid, also known as vinegar. Whenever you see a molecule with this group, you know it's got a strong personality and can easily donate a proton, making the solution acidic. Next up, we have the ester family. For the ester family, the functional group is a carbon atom double bonded to an oxygen and also bonded to an OR group. In organic chemistry, the R, as seen in this functional group, stands for any carbon-based chain like methyl, ethyl, or propyl, making it more flexible to represent various organic compounds. Esters are actually derived from carboxylic acids, with the OH replaced by an OR group, giving them their fruity aroma. They have OATE, OATE as their signature ending, as seen in ethyl ethanate, which smells like pineapple. Now we have the amino family, which is basically found in amines. And in the amino family, it is basically a nitrogen atom bonded to two hydrogen atoms and attached to a carbon. Their names end with amine, like in methylamine. This makes amines basic and highly reactive, ready to accept a proton. Next, we have the ether family. In this, an oxygen atom is bonded to two alkyl or aryl groups. Esters are basically the peacekeepers. They connect two groups of carbons with an oxygen bridge, making them the mediators of the chemistry world. Their names might include ether, or they use the alkoxic prefix, as in diethyl ether or methoxybenzene. They are not overly reactive but are crucial in forming balanced solutions. Now we have the alkene family. The alkene family members have a double bond between carbon atoms. Their compounds end in E and E are seen in propene. This double bond makes the alkene family more reactive than its single bonded relatives, the alkanes. So think of the alkene family as a young, energetic family that is always ready to get involved in a chemical reaction. Finally, we'll talk about the alkyne family. The alkyne family takes things up a notch with a triple bond between carbon atoms. Their compounds end in YNE, like propyne. This triple bond gives them a sharp reactive nature, making them quick to participate in chemical transformations. So to wrap up, these functional group families are the building blocks of organic chemistry. They shape how a molecule behaves and interacts with others. Understanding these families and recognizing their nature helps to make sense of the vast world of organic compounds. So whether it's a friendly hydrosol or a wild carboxylic acid family, each member plays a unique role in chemistry's big picture.